So in order to find out the second derivative, we start from dy dx once again. That is, we are starting from 1, differentiating both sides. With respect to x, we get d2y dx2 is equal to minus y into ddx of 1 plus log x, which is simply 1 by x, plus 1 plus log x, better you take the negative sign outside the bracket, into dy dx. Okay. So this, you get this as minus y by x plus 1 plus log x dy dx. This is what d2y dx2 is. Now at x is equal to, because we want to check the sign of the second derivative, at the point x is equal to 1 by e, d2y dx2 is equal to minus, now what is y? Before finding out d2y dx2, let's first find out y. What is the value of y at x is equal to 1 by e? Then we'll find out at y is equal to, the given function was 1 by x to the power of x, right? So put the value of e here, 1 by e to the power of 1 by e. So you get e to the power of 1 by e. So at x is equal to 1 by e. Now we'll check for the sign. d2y dx2 is equal to minus, now y here we have got e to the power of 1 by e, divided by x is 1 by e. Plus, now dy dx at x is equal to 1 by e, if you see, the value of dy dx is 0. So we put this equal to 0. So what you see here, since the value of e is always positive, e to the power of 1 by e by 1 by e with a negative sign, this will be 0. Therefore, at x is therefore fx or y has a local maxima at x is equal to 1 by e. And what is the maximum value? Of y is, put the value 1 by x, which is 1 by e, to the power of 1 by e, which will give you e to the power of 1 by e. And that is the maximum value. Okay, so that should be it for this problem. Now we move on to the applied problems. Now applied problems require, apart from the conditions of maxima and minima, the applied problem will require a little bit of understanding also of the problem. You will have to read the problem very carefully, okay, and see what is given. Whatever is given will be your either variable or constant. Now you will have to also separate the variable and the constant. You will have to define the variable and you will have to define the constants on your own. Look at the first problem. The question here is divide 20 into 2 parts so that the product of the square of one and the cube of the other may be the greatest possible. So how should you divide 20 such that if you take the square of the other and if you take the cube of the, if you take the square of one and if you take the cube of the other and if you take the product, that product will be the maximum possible or the greatest possible. So I start by saying let 20 be divided into two parts. X and 20 minus x. Okay. So what is the product of the square of one and cube of the other? Part. Okay. You can take what is the two parts are x and 20 minus x. Square of one, cube of the other. It is better to take the cube of x and the square of 20 minus x. This is the product of the cube of one and the square of the other. You can take the other way also, 20 minus x whole cube into x square. It will come to the same thing. Okay. So now I say let y is equal to this. Now this is the function that we are getting. Right. Now if you see the question states that the product may be the greatest possible. That means we need to maximize y. In this we need to maximize y. And how do you maximize y? First of all, you find out the first derivative. Dy dx, differentiate this by u into v rule, 3x square into 20 minus x whole square plus x cube into 2 into 20 minus x into minus 1, right? Which is 3x square into 20 minus x. You can take or just simplify this, then you can take common. So from these two, you can take x square into 20 minus x common. You are left with thrice 20 minus x minus 2x. So you get x square into 20 minus x. This becomes 60 minus 3x minus 2x. So this becomes x square into 20 minus x into 60 minus 5x. Okay, now for maximum or minimum y, we have the first derivative must vanish. That means you get x square into 20 minus x into 60 minus 5x is equal to 0. That means either you will have x is equal to 0, or you can have x is equal to 20, or you can have 60 minus 5x is equal to 0 will give you 12. So these are three values that you need to check. Okay. Now, for what value we'll get the maximum product or the minimum product, we need to check with the sign. So first we find out d2y dx2 and then check the sign for each of the values of x. Okay. So how do you find d2y dx2? So if we write, we have dy dx is equal to 3x square into 20 minus x whole square minus 2x cube into 20 minus x. This was what dy dx we had got. Now, why am I using dy dx once again? Because I'll simplify this and then I will differentiate it once again to get d2y dx2. Okay, so 3x square, if you expand this by a minus b whole square form, you will get 400 plus x square minus 40x. And if you multiply all this, you'll get 40x cube minus 2x to the power of 4. So you get 1200x square plus 3x to the power of 4 minus 120x cube minus 40x cube this should be plus, I think. Yes, this should be plus, because if you open the brackets, you'll get a plus. So you get plus 2x to the power of 4. So you get here 5x to the power of 4 minus 160x cube plus 1200x square. Now, because I have multiplied dy dx, now it is convenient for us to differentiate this. So therefore, d2y dx2 is equal to 5 into 4x cube minus 160 into 3x square plus 1200 into 2x. So that you will get this as 20x cube minus 480x square plus 2400x. So once we have got d2y dx2, at each of the points we are going to check. At x, check the sign for d2y dx2. So at x is equal to 0, d2y dx2 is equal to 20 into 0 cube minus 480 into 0 square plus 2400 into 0, which is equal to 0. Okay, so that means at x is equal to 0, a second derivative also vanishes. That means we need to check with the third derivative now. d3y dx3. Find out d3y dx3. d3y dx3 will come out to be 20 into 3x square minus 480 into 2x plus 2400, which will be equal to 60x square minus 960x plus 2400. So at x is equal to 0. Now for d3y dx3, we don't need to check the sign. We just simply need to check whether d3y dx3 is equal to 0 or not equal to 0. Put it here, 60 into 0 square minus 960 into 0 plus 2400. So we see that we are getting this equal to 2400, which is not equal to 0. What do we say then? We say thus, what had we taken the function as? We had taken the function as y. Thus y has a point of inflection at x is equal to 0. Okay, so this is for x is equal to 0. Now we check for what is the other value of x that we had got here? We had got for x is equal to 0, we check, we got a point of inflection. X is equal to 20, now we are going to check the sign of the second derivative. At x is equal to 20. d2y dx2 put it in the expression for d2y dx2. You get 20 into 20 cube, 20x cube minus 480 into 20 square plus 2400 into 20. Okay, this you will get as 16,000, which is greater than 0. So what can you say? At x is equal to, the y has a point of local minima. Thus y has a point of local minima. at x is equal to 20. Now, what do you need to find? Do we need to find out the minimum value of the product or the maximum value? That is, the product may be greatest possible. So we don't need the minimum value. Okay, so we'll keep it here. We don't need to find out the minimum value. So that means x is equal to 20 also. We are getting a local minima, so we keep it at that. We don't need to find out the minimum value. What is the other value of x that we need to check? We need to check at x is equal to 12. We had got three values. So at x is equal to 12, now we check for the sign of d2y dx2. 20 into 12 cube minus 480 into 12 square plus 2400 into 12. So this, you simplify, you will get this as minus 5760, which is negative. So what can we say? Thus y has a point of local minima. Local maxima, not minima, because the second derivative is negative, at x is equal to 12, right? So at x is equal to 12, this product here that we have formed, y is greatest or maximum. So therefore, what are the parts we need to break this up into? Therefore, the two parts, therefore, the two parts for which y is maximum or greatest are 12, one part, and what is the other part? 20 minus 12. That is 12 and 8. That is, if you break 20 into two parts, 12 and 8, only then the product will be maximum possible. If you multiply 12 and 8, you will get 96. If you break 20 into any other part, you will get all the values that are or the 20 for which y is maximum. That means this product, not the product. You can check it here. Okay. If you break this up as 12 cube into 8 square, this product will be the greatest. Any other combination that you try, even if you try the combination of 10 cube, 10 square, even this will be less than this. Okay, any other combination, even if you try say 2 and 18, even then 2 cube into 12 square will be less than this. Okay, so this is what. So I hope this is clear, and move on to the next problem. You have to be a little patient with these problems. Okay, this is not just simple differentiation or simple integration. Next question here is, a rectangle is given whose area is constant. Prove that the sum of the lengths of the sides is greatest when it is a square. So you have a rectangle whose area is given. Whose area is A. Okay. Let us call it as PQRS because A we are using as the area. Okay. So area is given to be A. So here Now, as I said, you have to see what is given. So area is given, that means area is constant. Whatever is given to you, that will be constant. And whatever you will be assuming, that will be the variable. So area of the rectangle is equal to A. So A here is a constant because this is already given to you. Okay, now the question is, what should be the length and breadth of the rectangle so that the area is maximum? That means they're actually asking you to prove that length is equal to breadth. When the area is maximum, the length must be equal to breadth. That is what they ask you to show. But we'll take the length as L and we'll take the breadth as B. So let the length and breadth of the rectangle be L and B respectively. So therefore, L into B must be equal to A, right? Let's call this 1. Now this 1 is a very useful relation which we shall be using later on. Now, what is the variable that you need to maximize? You need to maximize the area. So we'll find out the, you need to maximize the, okay, sum of the lengths of the side. That means perimeter. That means you need to maximize the perimeter. See here, prove that the sum of the lengths of the sides is least. Okay, so now we'll find out the sum of the length of the sides. Sum of the lengths of the sides. Let us call this sum of the lengths of the sides as P, perimeter, is equal to, what is the perimeter of rectangle? Twice L plus B, right? Now we'll now see, we need to maximize P, right? We need to maximize P because the question is, prove that the sum of the lengths of the sides is least. We need to minimize, not maximize. Least they are saying. So we need to minimize P. Okay, but P has two variables, L and B. You can write here, L and B, because we have defined them. L and B are both variables. Okay, now we need to minimize P, but P has two variables, L and B. So we bring it down to one variable. How do we bring it down? We use 1. So from 1, we have breadth B is equal to A by L. Putting this value in 2. Let us call this as 2. We get, what is the expression for perimeter we are getting? P is equal to twice L plus A by L. Now P is in one variable, which is L, right? Now we need to maximize this. How do we maximize this? First derivative, dp dl, because L is a variable, we'll differentiate it with respect to L. dp dl, we'll get this as twice 1 plus A into minus 1 by L square, which is equal to twice 1 minus A by L square. Right? This is what we are getting as dpdl. So for maximum or minimum P, we have dpdl is equal to 0. For turning points, that means we get twice 1 minus A by L square must be equal to 0. That means 1 minus a by L square is equal to 0. That means a by L square is equal to 1. Right? That means you get a is equal to L square. Now, since L we had assumed L is our variable, we'll find a in term L in terms of a. So L is equal to square root of a. So at a is equal to, now we at L is equal to root a, p can be minimum or maximum, right? Now we need to find out the second derivative. So dp dl we have got as twice 1 minus a by L square. So therefore d2p dl2 is equal to twice 0 minus a is a constant. You can take it out of the differentiation, and you get minus twice, and L to L 1 by L square you can write as L to the power of minus 2, which if you differentiate you'll get minus 2 L to the power of minus 3, which you get this as twice of 2a L cube, which is equal to 4a L cube. Now at L is equal to root a, d2p dl2 is equal to 4a into root a cube, right? Which is obviously positive. That means at L is thus P has a local minima at L is equal to root a, right? That was what we have wanted to do. See, we needed to minimize P, and we are getting a point of local minimum at L is equal to root a. Thus P has a local minima at L is equal to root a. Now, if the length is equal to square root of a, then what should be the breadth from 1? What was the breadth? A by L, right? Now, when L is equal to root a, what is the breadth? A by root a, which is equal to root a into root a divided by root a. So 1 root a cancels, right? So that means you get breadth is equal to root a. So what does it show? This shows that the sum of the sides, sum of the lengths of the sides of the rectangle is minimum when L and B both are equal to root a. That is, when length and breadth are same, what do we call it? We call it a square. That is, when the rectangle is a square. Okay, that is what you have to show. I hope this problem is clear.
Yes, sir.
So in such problems, you need to little bit of understanding, and I think you will find it tough in the examination if this kind of problem is given. So unless you practice a little, now in this module that I have sent you, this module that I am solving for you, this covers all the variations of the problem that can come in your exam, in your textbook. Whatever variation from maxima and minima is there in your textbook, this set of problems covers all the all the various possible types of problem that you can get. So if you understand these problems, maxima and minima applied problems shouldn't be a problem for you. Shouldn't be much of a problem for you, in fact. Let's see number 3. The length of the perimeter of the sector of a circle is 20 centimeter. Length of the perimeter of the sector of a circle is 20 centimeter. What does this mean? We'll just understand this problem. We'll continue this problem in the next class. Okay, now if I draw a circle, here we are talking about only the sector of the circle. If we take the center of the circle here, this becomes the sector of your circle. Okay, let's see the length of the perimeter of the sector of a circle. What is the sector? O, P, Q. This is the sector of a circle. What do you mean by the perimeter of the sector of the circle? If I take the radius as R and this radius is also R, then R plus length of this R, PQ, is clearly the perimeter of the sector, right? So once we know this, now let's see what the problem states. The length of the perimeter of the sector of a circle is 20 centimeter. So this is perimeter of the sector is given 20 centimeter. Give an expression for area in terms of R and hence find the maximum area of the sector possible. So if you see here, given is the perimeter of the sector. Equal to 20 centimeter. It could have also been given to you as P. Okay, if it was given instead of 20, if it was given as P, then P would have, we would assume it to be constant. But here it is given to be 20 and you know 20 to be a constant. So that's okay. Okay, so perimeter of the sector is given to be 20. So first we'll write down the expression. We'll just answer the first part and then we'll continue in the next class. If you see the first part is the length of the perimeter of the sector of a circle is 20. Give an expression for the area of the sector in terms of R, the radius of the circle. So radius of the circle is already given to you, right? You simply need to find out the expression for the perimeter of this. Okay. Now if I say let the angle subtended by the sector at the center be theta. Let the angle subtended by the sector at the center be theta. So therefore, what is the length of this arc PQ? You can write here theta is a variable. Okay. Length of the, and also R is a variable. Although R is given to you, but R is also a variable because R depends on theta. So length of the arc AB. If you remember from your first chapter in trigonometry, when I had started in class 11, I told you that if the radius is given, and if theta is in radians, then the length of the sector, length of the arc, not arc AB, this is PQ. Length of the arc PQ is R theta. If you remember, in the first chapter I had discussed. And what should be the area of the sector in terms of R and theta? Half R square theta, if you remember. These two relations I had given you in the beginning only. Okay, so length of the arc is PQ is R theta. So therefore, what should the perimeter of the sector? Let's call this as P is equal to perimeter of the sector is OP plus OQ plus arc PQ. So r plus r plus r theta, which is equal to 2r plus r theta. So that answers the first part of the question. So therefore the required relation and what is the perimeter given? Sorry, this is the perimeter. And what is the perimeter given? Here 2r plus r theta is equal to 20 is given to you. So this must be equal to 20. So that means you get r into 2 plus theta is equal to 20, which is the required expression. Okay, this is the expression that we are getting for the perimeter of the sector. Okay, now we want to find out the expression for the area of the sector. Okay, so let's call this 1. So what is the area of the sector? If you remember, I had given this to you as half r square theta, where theta is in radians. Now we want, if you see the question here said find the area of the sector in terms of r. That means theta is not required here, right? So from 1, with the help of 1, we are going to remove theta. So from 1, r, let us call this 2, r into 2 plus theta is equal to 20. That means you find out theta in terms of r. You get 2 plus theta is equal to 20 by r. That means theta you get as 20 by r minus 2. Putting this value into, let's call the area of the sector as A. Putting this value in 2, we get A is equal to R 2 plus 20 by R square, no? This is a half R square theta. Half R square and the value of theta you put 20 by R minus 2. Okay. So you get this as A is equal to, if you multiply half R square throughout, you will get this as 10R minus R square, which is the required expression for the area. So what have we done here? Perimeter was given as 20 centimeter. We found out the expression for perimeter in terms of r and theta. And this is the equation that we got in terms of r and theta, because perimeter was given to be 20. So we got a relation between r and theta. We called it 1. Now the question was find out the expression for area in terms of r only and not in terms of theta. So therefore we use the relation half r square theta. And because we did not require this theta, we put from 1, we put the value of this theta here. And we got the expression for A in terms of R only. Now, why did we get A in terms of R? Because see, the later part of the question, it states that find the maximum area of the sector. So in order to find the maximum area of the sector, you will have to differentiate this. And if there are two variables, if suppose in the area, if we had half R square theta here, we had two variables here, we could not have been able to differentiate. Therefore, we brought down this to one single variable. And then it will be easier for us to differentiate. Okay, so I'll stop here, and the second part of the question I will continue tomorrow.